Okay, so your do now is projected up here, and I'm going to give you about 3 minutes to work on it if you haven't already. It's okay for you to talk to your group members after you have thought about it on your own. Okay, so we know that the relationship is linear. What does that tell us? Ben?
No.
That it stays in a straight line. What else does it mean? Caden? There's a linear equation that can be written. Yes. Yes, I know Ben has his hand up. I just want to hear from someone else. Blake?
It has a slope.
It has a slope. Michael? Yeah, but another word for slope. Just use a synonym.
It has. No, I was thinking
It is going to have a y-intercept. We're not quite there yet, but slope or a rate of change. Okay, so I'm interested in what the slope was, but more than that, I'm interested in how you found the slope. Now, I'm not assigning roles because there's not a lot of somebody's got to write on the board, somebody's got to hold the board up. So I'm just going to try to make sure that I hit every group. David, was there at least one person in your group who was able to calculate the slope? You did, right?
Yes, but it's slightly incorrect. I think you got it right.
All right, so what's your general consensus to what the slope is?
We think that the slope is 1 over 3.
1 over 3. Anybody get anything different? All right, so we're agreed 1 over 3. And did you get 1 over 3 at this table?
Yes.
Yes. How did you get 1 over 3?
I used the equation y2 minus y1 over x2 minus x1.
Okay, and that's a great thing to do, but we don't have ordered pairs. So how did you establish what was y1, y2, x2, x1?
I actually thought that the x on top of the y was the ordered pair. Like -3 and 3, that's x1 and then y1.
Okay, so you're right. From the table, we can generate an ordered pair. Anybody else do anything different than the slope formula? Blake, how about you?
I used the graph and I did rise over run.
There's no graph here.
I calculated the points on the graph.
So you took this information, created a graph, and then tell me again?
I used rise over run.
Okay, so that's using the formula, rise over run. Anybody else do it any other way? Kareem?
I kind of did mine on the gentle math way. I did y, it's 3 to 4 is 1, and then -3 to 0 is 3, and then I did 3 to 5 is 2, and then -3 to 3 is 6, and I use that fraction to get 1.
Okay, I might need you to walk me back through that. I heard you say you went from 3 to 4, which was 1, and then from -3 to 0, which is 3. So when you went from 3 to 4 and got 1, what do we call that thing that you found mentally? Michael? Kind of. Change. Oh, you know, you guys got to reach back further than that. Change in, what variable is this? Change in y, and when he found, or delta y, and calculating this was delta x, change in x. Change in y over change in x. So the change in y was 1, the change in x was 3. Put that in that ratio, and we get the same 1/3 that Nikki got, the same 1/3 that Luke got when he used the formula, and the same 1/3 that Blake got when he calculated it that way. Okay? All right, we're going to shift gears now from our do now to our next activity. So if you can look at page 115 in your book, and I'll transition up here. All right, so you can see we have slope-intercept form, our math title, and working under pressure, which is our context title. So what we have here at the top is a paragraph of introduction, and I want you to go ahead and read that introduction, but I have a very specific task for you while you read. You know I'm always saying mark the text, mark the text. I feel like a broken record, but a lot of you are still not marking the text, so I'm going to be super specific. I want you, when we're going through this, to circle the words that indicate a mathematical operation. So you're going to circle the words that indicate a mathematical operation. You can feel free to mark other important information as well. And I was wondering if one of you would like to read this paragraph. All right, Luke.
When a diver descends in a lake or ocean, pressure is produced by the weight of the water on the diver. As the diver swims deeper into the water, the pressure on the diver's body increases at a rate of about 1 atmosphere of pressure per 10 meters of depth. The table and graph below represent the total pressure, Y, on a diver given the depth, X, underwater in meters.
Okay, thank you. Who's already circled something? Nikki, tell me one thing you circled.
Increase at a rate.
Increases at a rate. And what mathematical operation do you think increases is indicating?
Slow.
There's only 4. Here they are. Addition, subtraction, multiplication, division.
Sorry, multiplication.
Okay. I was thinking of another one.
I was thinking of addition as well.
Okay. Increase could be addition or multiplication. I think in this case it means addition. Blake, did you circle something?
Oh yeah. The table and graph.
Okay, we're looking for words that indicate a mathematical operation, although I would agree the table and graph, super important, and something we want to look at and notice details of. Jenna, mathematical operation?
Multiplication.
Yes, I agree. So I want you to have that in your head. I want you to look at this graph. I want you to notice the signal boxes. So we have a lot of text features here. We have a table, we have a graph, we have 1, 2, 3, 4 signal boxes on this page. I want you to pay particular attention to the academic vocabulary. So give yourself about a minute to do that. And then I want you to complete numbers 1, 2, and 3. So 1, 2, and 3, I'm going to give you a total of 5 minutes. Okay. We missed the 3. We just went to the 2, 1. Justin, do you have an equation?
Yeah.
What do you have?
Y equals 0.1x plus 1.
Okay, I'm going to grab the stylus and a color, and we'll see how this goes. So you have y equals, keep going,
0.1.
there's my decimal. Okay,
X plus 1.
okay. Phew, painstaking. Thank you everyone for your patience. Not my best work, but not my worst work. I'm not always going to write on there. I just think that was important to get up there because there were some things I wanted to look at. Did anybody like me mark something else in the text besides the math operations that I told you to look for, Caden?
Oh, remember?
Okay, I guess I could never mind. I was hoping you would tell me. Jenna?
It says for it increases at a rate of 1 atmosphere of pressure per 10 meters.
Atta girl. Well, still not my best work, but you get the picture. Okay, and I was really, really interested to notice that while this said 1 atmosphere of pressure per, there's the multiplication that you guys talked about earlier. I think it was actually you, Jenna, that mentioned it. 1, but in my chart, it's increasing by 1/10 or 0.1. And I thought, honestly, I wonder if they're going to be able, if they're going to pick up on that, which obviously you did, so I'm glad about that. But why is it 0.1x and not 1x? Sam?
Because you're not going immediately 10 meters. Like, x isn't going up by 10 meters, it's going up by 1 meter.
Right. X is going up by 1 meter, and it's 1 atmosphere of pressure for every 10. So this, in fact, is the correct equation. And if we look at this equation, we should be able to determine what the slope is. What is the slope of this line? Just based on our previous knowledge of slope, whether you use the table, the graph, or the equation. Max?
1/10 over 1.
1/10 over 1, which that's kind of a fraction in a fraction, so we could probably just say 1/10. And what are the units? Meters. And what is the y-intercept of this line, Kira? The y-intercept is 1. What does that mean? Who can, what's that mean in our situation? Michael?
In the situation, the diver, didn't start at the bottom. I'm sorry.
How deep is the diver at the y-intercept?
Is 1
What's
yes,
x is the depth, and the depth is
mm,
what right here? 0.
so he's out of the water.
Or he's just not going down, right? And how many atmospheres of pressure is it? 1. Now, for me, this was really frustrating. I read the page and read the page. I read the Connect to Science. I asked Mr. Connally, who used to be a science teacher, or I guess he still is a science teacher, just not currently teaching. And I said, wait a minute. So that means that there's 1 atmosphere of pressure before you even go anywhere. And he said, yes. So I said, so that means like right now I'm like carrying 15. I came over here and I said, so I'm carrying about 15 pounds of, there's 15 pounds of pressure on me. No wonder I feel so tired all the time. Yeah, that's the place where you laugh. Okay, so anyway, I don't really know how all that works, but I do know this. If the y-intercept is 1, that's where x is 0. That tells me that before he descends at all, at 0 depth, there's an atmosphere of pressure. So the y-intercept of the line, we also have to be able to interpret. Okay, we're going to go down and we're going to look at this box. You guys know that anything in a box is important, right? So I'm going to move the page here. Clear my stuff off. And we have more academic vocabulary, talks about the y-intercept of the line. I cannot stress enough how important these vocabulary terms are going to be to you, for you. And then in the box we have slope-intercept form of an equation, defined how. How are we defining slope-intercept form of an equation? Nikki?
Y equal mx plus b.
Y equals mx plus b, and m is the slope, and b is the y-intercept. I have no idea why they chose those letters, but they did. And there's been internet research done, and I don't even think mathematicians can agree. So I want you to take that information in the box, and I want you to do number 4. It's only going to take you about a minute, and that's all we basically have on this video anyway. So I'm going to pause it and let you answer it, and then we'll come back and discuss. Okay, so answering this question should have been as elementary or as just basic as comparing what you have in the box to the equation right here, which means you should be able to look at it, and let's see if we can do this all together. Tell me that the slope is?
-2.
And the y-intercept is?
9.
Right, so the slope-intercept -2, y-intercept 9, and we will catch everyone in the next video.